theta and this as our sin theta. Squaring and adding, what we get? 3 square, 4 square, r square common, cos square plus sin square is equals to 1. So by taking LCM we get r as 1. Dividing these equations, r sin theta, r cos theta, 4 by 5, 3 by 5. So tan theta is this, so theta is tan inverse 4 by 3. Theta is tan inverse 4 by 3. Now instead of 3 by 5, put here value of r is 1, cos theta, cos of x, plus sin theta, sin of x. Now use the formula here, cos A, cos B, plus sin A, sin B. That is equals to cos A minus B. Cos A minus B. We can write it as x minus theta or theta minus x, because cos of minus theta is also cos theta. So what we get here? X minus theta. And what is the value of theta? Tan inverse 4 by 3. So x minus tan inverse 4 by 3. Similarly for second part, x minus theta, theta is tan inverse 4 by 3. Now put 5 by 13 as r cos theta or sin theta. We want the term sin here. Sin A cos B plus cos A sin B. So put this as sin and this as r cos theta. Squaring and adding, 5 square, 12 square, r square, sin square plus cos square is 1. By taking LCM, this will be equal to 1. So we get r as 1. On dividing, r sin theta upon r cos theta, r sin theta 12 by 13. So we get 5 by 12. Tan theta is this. So theta is tan inverse 5 by 12. Now put the value sin inverse sin theta cos x plus cos theta sin x. Use the formula here. Sin inverse sin A cos B plus cos A sin B. Sin A plus B. That is equals to theta plus x. And what is the value of theta? Tan inverse 5 by 12 plus x. The next one is simplify sin inverse sin x plus cos x upon root 2 minus pi by 4 less than x less than pi by 4. Now we can write this 1 by root 2 as 1 by root 2 sin x plus 1 by root 2 cos of x. Here we have the function of sin inverse. So in the bracket we want the term of sin. 1 by root 2 is the value of sin pi by 4 and cos pi by 4. Here we have sin. So write this as cos. Here we have cos. So write this 1 by root 2 as sin. Now use the formula sin A cos B plus cos A sin B. That will be equal to sin A plus B. Now sin inverse sin theta will be equal to theta if limit lies between minus pi by 2 to pi by 2. This is the value of x. Add pi by 4 here. Pi by 4 plus pi by 4. Limit lies between minus pi by 2 to pi by 2. So this value will be equal to x plus pi by 4. This is second part. Cos inverse sin x plus cos x by root 2. Similarly, cos inverse 1 by root 2, here is sin pi by 4 sin x plus cos pi by 4 cos x. Now here use the formula cos A cos B plus sin A sin B, cos A minus B, x minus pi by 4 or pi by 4 minus x, same thing, because cos of minus theta is cos theta. So we get it as x minus pi by 4 when limit lies between 0 to pi. Now this is 0 to pi by 2. So limit lies between 0 to pi. For this the limit is pi by 4 less than x less than 5 pi by 4. Now add pi by 4. Subtract pi by 4 from here. 5 minus pi by 4. So limit is between 0 to pi. So cos inverse cos theta will be equal to theta, that is x minus pi by 4 here. Prove that sec square tan inverse 2 plus cosec square cot inverse 3 is equals to 15. Sec will be get cancelled with sec. Sec inverse and sec will get cancelled. Here we have square of this. So we can write it as tan inverse 2 square. Similarly, cosec cot inverse 3 square, we can write it as this. Now tan inverse 2, let tan inverse 2 is equal to theta and cot inverse 3 is equal to phi. So we get cot phi as 3 and tan theta as 2. Tan is perpendicular upon base. If this is angle theta, perpendicular and base. Hypotenuse is perpendicular square plus base square, so we get as root 5. Here we have sec, so we want sec theta here. Cos is b upon h, so it will be h upon b, root 5 upon 1. So we get theta as sec inverse root 5. This is also the value of theta and this is also theta. Now cot b upon p, base, if this is angle phi, base upon perpendicular, 3 square plus 1 square, so square root of 10. Here we have cosec, so cosec of phi. Sin is p upon h, so it will be h upon p. Perpendicular is 1. So we get phi as cosec inverse root 10. This is the value of phi. This is also the value of phi. So instead of tan inverse root 2, put here sec inverse root 5. So in the next step, write it as sec inverse root 5 square plus cosec of cosec inverse root 10 square. So we can write it as root 5 square plus root 10 square. So 5 plus 10, that is equal to 15. Now the next is prove that sine of cot inverse cos of tan inverse x is equals to root of x square plus 1 x square plus 2. First, we have to solve this bracket. Tan inverse is there and outside the function is cos. So we have to write in the term of cos. So put tan inverse x as theta. So tan theta is x. Tan is perpendicular upon base. Hypotenuse is perpendicular square plus base square. Here we want the term of cos. So cos of theta is base upon hypotenuse. So from here we get theta as cos inverse this 1 upon square root of x square plus 1. So put this value here. Sin cot inverse cos of cos inverse 1 upon 1 plus x square. Clear? Cos and cos inverse will get cancelled. So we get it as cot inverse 1 upon 1 plus x square. Now put cot inverse 1 upon 1 plus x square as phi. So we get cot phi as 1 upon root 1 plus x square. Tan is perpendicular upon base, so it will be base upon perpendicular. So base is 1, perpendicular is this. Now hypotenuse is perpendicular square plus base square. So 2 plus root 2 plus x square. Now this is cot. Outside the function is sine. So we want the value of sine here. So sine is p upon h. Perpendicular upon hypotenuse. So we can write it as sine instead of cot inverse phi. Phi is also sine inverse this. So sine inverse root of 1 plus x square 2 plus x square. Now sine and sine inverse will get cancelled and we get the result as 1 plus x square or x square plus 2. Now second part of this question. Prove that cos of tan inverse sine of cot inverse is equals to root of x square plus 1 x square plus 2. Again by using same procedure. Put cot inverse x as theta. So we get x as cot theta and cot is base upon perpendicular. If this is angle theta, base perpendicular. Hypotenuse is perpendicular square plus base square. Here we have sine. So we want the value of sine here, p upon h. 1 upon square root of 1 plus x square. So theta is sine inverse 1 upon square root of 1 plus x square. Put this value here. We get cos of tan inverse sine inverse 1 upon square root of 1 plus x square. Sine and sine inverse will get cancelled. So tan inverse 1 upon 1 plus x square. Now put tan inverse this as phi. Tan inverse 1 upon square root of 1 plus x square. So tan phi 1 upon this. Tan is perpendicular upon base. If this is angle phi, perpendicular base. Now hypotenuse is perpendicular square plus base square. That is 2 plus root x square. Outside is the function of cos. So cos of phi base upon hypotenuse 1 plus x square 2 plus x square. That is phi is equals to cos inverse square root of 1 plus x square or x square plus 2. Put the value here. Cos of cos inverse square root of x square plus 1 x square plus 2. Cos and cos inverse will get cancelled. So x square plus 1 upon x square plus 2 square root. and y is equals to sec of cot inverse sine tan inverse cosec cos inverse A, where A belongs to 0 to 1. Find the relationship between x and y in terms of A. Put sine inverse A as theta. Sine theta is A. Sine is P upon H. So this is hypotenuse square minus perpendicular square. Outside is sec. So sec theta, hypotenuse upon base. Put this value. X is cosec tan inverse cos cot inverse sec. Sin inverse A is equals to theta and theta is equals to sec inverse 1 upon this. Sec and sec inverse will get cancelled. So cosec tan inverse cos cot inverse 1 upon 1 minus A square. Now put this as phi. Cot inverse 1 upon 1 minus A square. So cot phi is 1 upon this. Tan is P upon B. So this is B upon P. Base upon perpendicular. So hypotenuse is perpendicular square plus base square. So 2 minus A square square root. So put this value in x here. So x is cosec tan inverse cos. Instead of cot inverse phi, value of phi we want in terms of cos. So cos phi is base upon hypotenuse. So phi is cos inverse 1 upon root 2 minus A square. So cosec tan inverse cos and cos inverse will get cancelled. 2 minus A square. Now put tan inverse 1 upon root 2 minus A square is equals to psi. So tan psi 1 upon root 2 minus A square. Perpendicular upon base. Perpendicular base. Hypotenuse is perpendicular square plus base square. 2 minus A square, that is 3 minus A square. Outside the function is cosec. So cosec of psi. Sine is P upon H, so it will be H upon P. Root 3 minus A square upon 1. So instead of tan psi, we write it as cosec inverse root 3 minus A square. Cosec and cosec inverse will get cancelled. So we get the value of x as root 3 minus A square. Solve up to here. So we get x as root 3 minus A square. Now we have to solve the value for y. So y is equals to sec cot inverse sine tan inverse cosec cos inverse A. Now put cos inverse A as theta. So cos theta is A. Cos is B upon H. So perpendicular is hypotenuse square minus base square. Now we want the value of cosec here. So cosec is H upon P. H upon P. So put the value y as sec cot inverse sine tan inverse cosec cosec inverse 1 upon square root of 1 minus A square. Cosec and cosec inverse will get cancelled. So y is sec cot inverse sine tan inverse 1 upon this. Now put tan inverse 1 upon 1 minus A square as phi. So tan is perpendicular upon base. If this is the angle phi, perpendicular and base. Hypotenuse perpendicular square plus base square. Now we want the value of sine here. So sine phi perpendicular upon hypotenuse 2 minus a square. Use this value. So we get y as sec cot inverse sine, and this is sine inverse 1 upon root 2 minus a square. So sec cot inverse 1 upon root 2 minus a square. Now put this function as psi. Cot inverse 1 upon root 2 minus a square. So cot psi 1 upon root 2 minus a square. Tan is perpendicular upon base. So this is base upon perpendicular. Let this as side, base and perpendicular. Hypotenuse is perpendicular square plus base square. Outside the function is sec. Sec is h upon b. Base is h is root 3 minus a square. Base is 1. So sec inverse root 3 minus a square. So we get y as root 3 minus a square and x as root 3 minus a square. So what we get? X is equals to y is equals to this. Squaring both sides, x square is equals to y square is equals to 3 minus a square.